Good afternoon, everyone. My name is Scebile Ntombela. I'm going to be your moderator for this evening. I extend a warm welcome to our presenter for today, Prof. Bokoro, and all attendees. Before we get started, I'd like to go through a few webinar considerations. Attendees are reminded to ensure the volume is turned up on their devices. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, this panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other. However, they are encouraged to ask the questions via the questions panel. A recording of the presentation will be made available on the SAIE YouTube channel, which is SAIE TV. The recording will also be made available on the SAIE website. Past presentations can be viewed on our website under the Events drop-down menu in the section Past Events and Webinars. This page is updated regularly, so ensure you check back as often as possible for new uploads. And subscribe to our YouTube channel for more uploads. A certificate of attendance will be issued to all attendees in a few weeks after the webinar. Thank you again for tuning in this evening. I'd like to start by introducing myself. I'm Scebile Ntombela. I'm employed by Eskom. My role there is to look after the refurbishment of assets in order to make sure that our plant comply with current technological practices and also complies with the regulations. I also serve as the SAIE Power and Energy Section Chair. Today, we are honored to have Prof. Bokoro, who will share his knowledge and wisdom and expertise on the Internet of Things. Prof. Bokoro joined the Department of Electrical and Electronic Engineering Technology in 2007 as a lecturer. He is currently a professor and head of department. As part of his leadership involvement in Faculty of Engineering and the Built Environment, Prof. Bokoro is a member of the FEBE Executive Committee, member of the School of Electrical Engineering Research Committee, as well as a member of the University Senate. He is also a member of the South African Institute of Electrical Engineers, a member of the Institute of Electrical and Electronic Engineers, and is professionally registered with the Engineering Council of South Africa. With his 13 years of experience in the DEET, Prof. Bokoro stands proud to have taught, supervised, and mentored hundreds of students, currently working in various sectors of South African economy, as well as beyond the South African borders. Prof. Bokoro's research interests are in condition monitoring and reliability protection of surge protective devices, power quality and renewable energies, as well as in engineering education. I will now hand over to Prof. Bokoro to share his presentation with us. Over to you, Prof. Bokoro.
Thank you, Scebile. Thank you very much for the presentation, and let me just greet the colleagues and friends that are connected to this webinar. It is indeed a great pleasure for me to spend time and speak about the Internet of Things, and as we will be doing tonight. Now, I don't have to go through my own presentation, as Scebile has already done that. So let me just go through the title of this talk, which is basically on the Internet of Things as an enabling technology for remote condition monitoring. And the focus is going to be on power system equipment. Now, when talking about the Internet of Things, there are certainly many things that can be discussed about that. But for the purpose of this webinar, I've actually decided to group my talk or my presentation in terms of three main parts. And the first part, and because of, given the narrow focus of this presentation on power system equipment, and if we talk about power system equipment, we're basically referring to the production, to the transport or the transportation of electricity, as well as the distribution of electricity. So electricity is actually the key commodity in a power system network. So given that importance, I think it will be proper for me actually to give a few highlights in terms of how electricity nowadays contributes to wealth creation and economic growth. So that will be the first part of the presentation, and that will lead us straight to the second part, which basically is all about the energy transition. And in terms of the energy transition, the key aspect there will actually form the core of this presentation. And talking about the core of this presentation, and that basically what we call here as the reliability and supply security of future energy systems. And it is basically in that particular field that we will get to discuss the role of the Internet of Things, which, by the way, will be the third part of this presentation. So three parts will basically consist of, will be the key of this presentation. Now, to start with this presentation, I would like basically to share some you know, the wisdom of former President of the United States, and since the United States is actually topical in this time, I think it will be perhaps proper for me to actually share what one of the former presidents of the United States actually stated when he indicated that a nation that cannot control its energy sources cannot control its future. I think this powerful word from former President of the United States, Barack Obama, will basically try to get us to think about the role of the Internet of Things in the remote condition monitoring of power system equipment. So let me start by really trying to position, you know, the issue about, like I indicated in my in one of the slides, in the content slide, when I spoke about the electricity as a commodity, as a key commodity in wealth production around the world. Now, the current trend, the current global trend as far as electricity demand goes versus supply availability, given the depletion of resources around the world, put the entire world in this particular position that you're actually seeing, whereby we have slow decrease in terms of the resources, or you have depletion of the resources that actually assist in the production or in the generation of electricity. At the other end, we have basically continuous growth in terms of electricity demand. So this is something quite interesting to think about, given the fact that it's actually some kind of a crossroad. How do we get to balance this? How do we get to balance the fact that we are facing supply depletion, which straight away leads us to supply security, and yet on the other side, given the fact that wealth production around the world requires basically electricity to be available. And that perhaps justifies what we're now witnessing around the world in terms of the increased demand in electricity. So that is actually an interesting problem to think about, which in fact can actually be again observed in this. If you look at the current versus the expected global rise in electricity demand. Now, if you look at this slide quite carefully, and thanks to the World Energy Outlook 2017, whereby this actually gives us an indication in terms of the growth in terms of electricity demand, such as projected in 2040. So we're looking at now in yellow there. It's actually those were the statistics in 2016, published in 2016. And in red, this is basically the growth, the expected growth in 2040. So you can actually see that it is expected that China basically will reach about 9,000 terawatt hours. And that is in 2040. And the United States is actually around just less than 5,000 terawatt hours of energy, electrical energy consumption. So you can actually see that the trends are actually looking quite, interesting in terms of electricity demand. But the question there is, with these trends, are we going to be able to cope? Are we going still to have resources to be able to meet these demands? That is an interesting question to be asked. And this is not just something that concerns China or United States, but you can actually see the European Union is also affected by the same thing. Even here in Africa, although if you look at electricity demand, is not something that you'll try to match to the one in the China one or the United States, but you could actually see there is some form of growth. Actually, in 2014, it is expected that in Africa, electricity demand will actually approach 2,000 terawatt hours. So there is growth basically around the world. Everywhere in the world, there is increased demand in terms of electricity. But why there is such increased in the need of electricity? And that is simply driven by wealth production, because you could actually see that electricity demand is somehow connected to wealth production. If you look at China, who's actually the second biggest economy, or if it's not the first, the second biggest economy with 15.86, and those states actually were taken in 2018, whereby China contributing 15.86% of contributing 15.86% of the world GDP. So you could see actually that could be matched with the demand in terms of electricity. So I would like to believe that as the GDP increases, as the share, China's share, or the United States, or any of the European countries, you could actually see it in green. That's basically European countries. You could actually indicate that you could, to some extent, relate electricity commodity to wealth creation around the world. Now, since most of these countries are actually perpetually trying to increase the GDP, you've got to expect electricity demand to increase. And if you look at our beloved continent, the African continent, you could see, although the GDP contribution, it's still not really something that you would like to actually match to that of some of the countries that are actually represented. But again, that doesn't stop, although there are quite a few issues in terms of access to electricity, but that in fact doesn't stop electricity demand to continue rising also in the African continent. Now, in case of South Africa, you could actually see the statistics, thanks to Stats SA, you could actually see electricity contribution towards the South African GDP. And you could see that in 2016, electricity, and when we talk about electricity in this particular case here, we're looking at electricity trade, you know, the manner in which, you know, electricity is being traded, you know, in the country. You're looking at the municipality buying power in bulk from Eskom and selling to their various customers, and that the entire thing actually contributed 2.4% of the South African GDP in 2016, and that actually you know, changes in 2017, because if you see in 2016, that was actually 2.4, and electricity features actually second in terms of growth. But if you see now in 2017, that actually decreased to 0.2% share of the South African GDP in South Africa. So that's, of course, is due, you know, is due to all the problems that we're having in the country in terms of electricity. Now, if we go to 2018, in 2018, you'll actually see that again, it's actually quite sluggish there, because it's more or less, it was more or less the same in 2017, and in 2018, actually that particular trend continued. All right, so we have a share of 0.2%. That simply the electricity share in the South African GDP. And in 2019, it's actually worsened. It's actually worsened. And the states that we have there features basically gas and water. But we know that our focus basically in terms of this talk is actually on the electricity. So that is to say that electricity is actually quite a significant or an essential commodity to actually indicate, you know, the path in which a particular country is at or on in terms of wealth production. So electricity is actually, you know, it is important actually to be aware of the fact that we cannot imagine or we cannot envisage economic growth without electricity commodity. So that leads us basically to all the challenges that, you know, the world is basically facing in terms of what is now known as the transition to future energy systems. Now, the transition to future energy systems now is basically driven by three key aspects. You know, this is what you call the sustainability. You know, there's the sustainability issues, and every time we talk about sustainability, we actually referring to our own environment. And then environment actually is directly linked to what I indicated in one of my slides when I spoke about depletion of the reserves that we have or that we use to actually produce electricity. So sustainability is actually one key aspect, you know, that is something to be considered, or is actually a part of the equation in terms of the transition to future energy systems. But there's also one of the actually key, and that will form actually the you know, the key focus of this presentation, which is actually energy security. And energy security is also another issue, and we did mention about it, and energy security will actually be the key focus of this presentation. And of course, we have energy access. Now, in terms of energy access, basically the plan is to reduce what is now known as energy poverty, because millions of people, you know, and particularly in the African continent, still do not have access to energy, to electricity. And the transition to future energy systems is actually guided by these three key aspects of things. And for those who are actually interested to know further about the future of energy systems, the key thing there is basically we're moving towards, you know, more distributed utilities as opposed to centralized utilities of today. And we'll get actually to see the role of that the Internet of Things can actually play in terms of the future of energy systems. Now, like I just indicated, these three key aspects, talking about sustainability, which is related to environment, energy security that basically relates to reliability of supply, and of course, energy access. Now, these main aspects or let me rather say that the attributes of future energy systems are actually driven by three important things, which are decarbonization, which is immediately related to sustainability, and then decentralization, which is basically related somehow to security of supply, and of course, access to energy. And there is also what we call digitization, which actually plays an important role. And that is basically will form the building block of what is now what will actually form the key focus of this presentation. So these key drivers, digitization, decarbonization, and decentralization, are actually driving, you know, the transition to future energy systems. But one question is actually important to be asked. Do we actually, can we, if we were to estimate when locally we can actually get into the realization of future energy systems? And this actually raises so many questions. And one of those is the fact that if we were to actually implement new techniques, should we wait until we are full in the energy systems of tomorrow before, or we can actually get to start modernizing the current system so that we can actually start implement new technologies? So these are the questions that we'll actually get to discuss as we move along in this presentation. Now, if you look at now, like I said, because this presentation actually focuses on the security, on the energy security, which is one of the key aspects of future energy systems. And when we talk about energy security, we want to focus on the supply reliability. And the reliability of supply basically is to some extent related to the need for monitoring. Because we need actually to know, yes, we can produce electricity. Yes, we can distribute electricity across the country. I mean, to consumers that's really need electricity for you know, in their businesses. But the fact of the matter is we need to be able to actually deliver to consumers the desired amount of electricity that they require, and that should be done within accepted standards. And that is basically what we refer to supply reliability. But one question remains to be asked. Are we able to actually do that, despite the fact that yes, to some extent, we can actually speak about the digitization that is actually there, but is it really helping? Are we still being able to actually meet this commitment, being able to supply or to deliver the required amount of electricity that consumers may need, and that should actually be done within accepted standards? Now, for the sake of measuring or for the sake of monitoring, if a distribution system in particular is actually quite reliable. Now, a couple of indices could actually be used. For instance, we have what we call the system average interruption frequency index, all right, or the system average interruption duration index. And usually these are actually used for the sake of trying to actually evaluate or to assess if the reliability of supply is to some extent being met. And this is actually quite a common thing. But the question that we need to ask is, despite these indices that have been used, you know, for quite some time now, one question remains to be asked, is that despite our ability, our current abilities to actually monitor these indices, to be able actually to determine that, but are they really helping us in terms of meeting our commitment, which is actually being able to deliver the correct amount or the required amount of electricity to consumers that require that and within accepted standard? And in fact, there are quite a number of, there is still a debate in terms of these indices. Because sometimes yes, we can actually, measuring these indices, being able to tell what is the SAIEE or what is the SAIEE, it's not really an issue. But is it really helping us? That is the question. And if you look at the current debate in terms of these indices, these debates basically relate to two things. How do you actually get to effectively calculate or to determine these indices? And also, there are issues about normalization, because sometimes given the weather conditions, for instance, can actually get you to have your SAIEE index actually to drop because of situations that are actually beyond, this is actually dependent, situations that are actually dependent on the nature, which no distribution operators actually could actually do anything to prevent that, to prevent such interruptions. So you still have issues whereby you cannot be able to actually give a guarantee to your consumers if you are actually on the distribution system or the distribution operator. You're still not able to actually guarantee that you can get zero interruption, in a particular system. But although zero interruption could actually sound like, it sounds actually like, this is madness, because zero interruption, you cannot talk about such a thing in the world. You still get interruption. But the problem is on the consumer side, what if that interruption happens at the moment when he needed electricity the most? And that is the issue. So we still have reliability. We still have reliability issues, despite the fact that we can actually tell, we can use indices to actually determine where are we in terms of reliability of supply, but still that does not help. And this is despite massive investment that are actually, or that have been put in place for the sake of improving reliability, supply reliability. So reliable monitoring and measuring systems are actually required. But this is not a question of just monitoring, because you may be able to monitor, but how does it help if you can monitor that there is interruption? Several consumers, for instance, are experiencing disruption in terms of electricity supply. It is good to know this information so that you can actually dispatch your technicians or network operators to come and resolve the issue. But fact of the matter is, already consumers are experiencing interruptions. Now, in terms of, if you look at the amount of investment that have been that has been there in terms of, for the sake of improving supply reliability. Now, you could see that ever since the history of distribution industry, I mean, the distribution systems, you could see that there's been massive investment in terms of putting in place reliable monitoring system to be able to actually improve reliability indices. For instance, starting from simple meters, nowadays we actually, in the space of distribution automation, and of course distribution automation, this is actually distribution automation is actually quite an achievement that many distribution systems today actually rely upon to try and improve their service, to try and improve the reliability of electricity supply. But despite that, we still, one simple question is, despite all the massive investment that have been put in place, despite the fact that we have sophisticated distribution automation systems, we can actually do what you call the visualization of a substation, for instance. SCADA systems are now in place to be able to actually visualize substation, feeder systems, and all these things. But still, we hear day in, day out about electricity in, supply interruptions, and sometimes for really longer duration, which can be devastating for an economy. So these are really so the major lesson to actually learn here is that despite this massive investment in reliability, in supply reliability, in a bid to actually improve that, but still we are facing issues. We are facing various issues. We're still not being able to actually reducing the number of frequency, the number of, in fact, the SAIEE or the SAIEE. So question is to be asked basically, are we really there in terms of technologies that are supposed to be in place to actually assist us to be able to detect the problems and resolve them timelessly? Questions need to be asked. Questions need to be asked about the efficiency of current monitoring systems or current technologies that are actually being implemented in distribution systems for the sake of improving supply reliability. And asking these questions basically prompt us to actually re-examine automated electricity distribution systems that we actually deal with. Now, if you look at the functions of a distribution automation, all right, in a distribution system, we actually basically look at three major things, which are substation automation. And in substation automation, you're looking at your data acquisition and supervisory control of devices such as your circuit breakers, capacitor banks, transformers, protective relays, etc. Right? And then you also look at feeder automation. Feeder automation and basically also look at quite similar function in terms of substation automation, in terms of data acquisition and supervisory control, of things like line reactors, and things like that. And then, of course, in terms of the customer interface automation, we're looking at automated meter reading, automated reprogramming of time of use meters, remote services, and etc. But still, the question is to be asked, have all these techniques really improved the SAIEE and SAIEE? And just to focus on these reliability indices, the question remains to be asked. These techniques are good and they've been there and they're working. This is not really to say that these techniques are useless. We're not at all saying that. All we're saying is, despite the usage, despite the application of these techniques, are we really doing justice to consumers in terms of reliability of supply? Because we would have actually hoped to say, look, we have invested such amount of money in terms of improving our services, and then that should have actually silenced all the complaints that we get to hear, because day in, day out, we hear about, substations or transformers being burnt out, things like that. So still, that basically forces us as engineers, as scientists actually involved in this space, to actually question the technologies, if really the technologies that we're currently employing are actually sufficient to be able to help us to actually reduce, to mitigate all these issues that we are facing. Now that leads us now to a fundamental question that which will actually lead us to the key focus of this presentation. Now, yes, we know about distribution automation. We know about all these SCADA systems and all these things, but perhaps the cognitive part is actually missing. And we're asking ourselves a question, will cognitive distribution automation perhaps be the response to supply security? It could perhaps be the response to that. And what is it, these big words that we're actually getting to know, to hear about? Cognitive distribution automation. What are we talking about? Well, we are now basically in the fourth industrial revolution, because the digitization that formed one of the drivers towards automation, towards substation automation, right? For the sake of improving energy access, for the sake of improving energy security, and of course, to actually be used for the sustainability of energy sustainability. And this, it seems like there is something that actually missing. And we hear day in, day out, people actually getting too confused what is known as automation and the cognitive part, which basically belongs to what is now known as the fourth industrial revolution. And when we speak about that, the fourth industrial revolution, and basically it's perhaps adding the cognitive part to actually try to solve all these supply reliability issues. And that is really the question that we're actually asking this evening. Will the cognitive, if we could possibly add the cognitive part to distribution, to the current distribution automation, will that really be perhaps the solution to our problems? And this is basically what we're trying to investigate, because the cognitive distribution automation, basically, what it gets to aid there, if you look at the current distribution automation, network infrastructure is already there. There are no issues about that. Communication protocols, it's there, no issues about that. But what could perhaps be missing here is actually the intelligence part, the analytics part, because if you look at the SCADA systems, with the SCADA systems, you could possibly draw, and this is what is happening currently, you could actually draw data in terms of circuit breakers, operation, and all that could actually affect a piece of device which could be important in a substation, or let's just say in a distribution system. You could actually possibly draw data. But what do we do with this data? Yes, we have significant amount of data, but if we added the intelligence part, the ability to actually analyze this data, to be able to actually assist us to actually respond to these security issues, to these energy security issues that we're still facing. And that is basically what we need to actually try and think about it. And doing some work in terms of, in this particular space, we actually, among the 4IR, the fourth industrial revolution technologies that are actually proposed, we have actually we have actually identified the Internet of Things as one technology which could actually be used to assist us in terms of the improvement of supply reliability. And this is what basically this talk is all about. Now, before we get to that, before we get to talk about that, we need to know then what is the Internet of Things, and people get to speak about Internet of Things and the fourth industrial revolution, and you hear day in and day out people actually confusing automation to intelligence, and that is even if you look at many products that are actually being are being used, and some people even today continue to actually refer to certain things, to certain product as an intelligent, and you get to hear things like that. Although it actually may not be the case, people may actually refer to the intelligent aspect as the automation part, which is actually not the case, because the automation, you could actually think of, think of a traffic light. A traffic light will actually, from 24 hours, keep on giving you the same sequence. It's green, amber, red, green, amber, red. There may not be a car, but it will still follow that sequence. So that is not intelligence, that is actually automation, because it has been programmed to actually follow a particular sequence. But it cannot think to actually be able to say, there is no traffic, there is no car coming on the other way, so let me just turn to green so that this car here can actually proceed. So it cannot get to that level. So the Internet of Things, being actually a 4IR technology, brings basically that ability. In fact, I would like to say it actually completes the current substation automation to actually make it cognitive, to make it intelligent, to actually enable it to be able to make a decision. That is actually the thing. For time's sake, I wouldn't want actually to go through to give the details of this, but in fact, let me just share a little bit, just to give you a blink of what is the Internet of Things. Now, I will refer to Dr. Tom Bradisic. Is actually a vice president of one of the well-known, well-established company, the Hewlett Packard, actually in the United States, and I think the company is also here in South Africa. Now, when invited to give a talk on the Internet of Things, he actually refers to the Internet of Things as basically a combination of 7 key principles, which he named them: big analog data, perpetual connectivity, really real-time, spectrum of insight, immediacy versus depth, and shift left next V. And basically, if you can transpose this into the 7 characteristics of what is known as IoT, talking about intelligent, smart, analytic, automation, decision, and all this, and ecosystem of community, and that is basically what an IoT, just to put you into perspective. But we can, in fact, define the IoT as a dynamic global network infrastructure with self-configuring capabilities based on standard and interoperable communication protocols, where physical and virtual things all right, have, let me actually, there is, all right, so I'm just trying to move something so that I can actually see that. All right, so we physical and virtual things have identities, physical attributes, and virtual personalities use intelligent interfaces and are seamlessly integrated into the information network. And this definition is basically according to the European Research Cluster of the Internet of Things. All right, and it's actually quite cumbersome. It confuses you more than it gets you to understand what really this technology is all about. Now, moving to the next, I've actually managed to get a more simple definition, which is from the IEEE society. The IEEE basically defines the Internet of Things as a network. This is what it is. It is actually a network of connected devices with unique identifiers in the form of an IP address, which, we're talking about these devices, have embedded technologies or are equipped with technologies that enable them to sense, and these are actually quite important, to sense meaning actually measuring, gather data, and communicate about the environment in which they reside and or themselves. Now, this technology converges the real, digital, and the virtual in order to gather intelligence. All right, intelligence here, we're actually gathering data for decision making, and this is actually the important thing, and this is where we want to reach. We want substation automation to actually become cognitive, meaning that it can actually, you have a circuit breakers connected to the Internet of Things, it can actually gather sense information, right, about current, and then be able to actually make decisions, And the same thing for all other devices. Now, this technology can actually be applied in various industries, in home automation, in the health space. It can actually be used in transportation, community, and national, and all that. It's actually quite a versatile technology, which enables us to actually have some form of a combination of technologies, a combination of 4IR technologies. For instance, when we'll get to remote condition monitoring, you'll see that you can basically use this for the sake of, you can actually use this in conjunction with some other 4IR technology to actually be able to achieve certain objectives. Right, now let's get to the condition monitoring now. The condition monitoring that we're talking about here, we actually refer to, the ability to actually monitor, right, to actually monitor a certain, certain parameters, because that is what condition monitoring is all about. Being able to monitor certain parameters so that we can actually gather intelligence and be able to make decisions about that. Now, if you look at what is known as the natural life cycle of a machine or an equipment, and this is basically what we're sharing over here. You could see that from the installation time of a product or a machine, you can actually, that is basically, and people who are in condition monitoring will tell you that, aging or failure, the commencement of failure begins from the day a product or an equipment or a machine is actually put into use. And this is basically what happens. But then we've got to avoid to actually reach a stage where we're doing what is known as preventive maintenance. Because when you do preventive maintenance, it means that failure is actually around the corner. You're just trying to prevent failure to happen anytime soon. But what is actually recommended in condition monitoring is what you call predictive maintenance. And in predictive maintenance, you're actually trying to keep this line actually in straight. You're actually trying to prevent this curving to actually take place. And that is the ability to be able to actually proactively tell what is the real condition of an equipment or a machine by simply gathering intelligence. And intelligence here meaning that constantly measuring, or it could be like vibration, could be temperature, it could be current, it could be actually anything. And this condition monitoring can actually be enhanced by this technology that we're actually promoting here, which is the Internet of Things. Now, if we couple the Internet of Things into monitoring systems, we can actually perfect, or we can actually improve condition monitoring of equipment. And this is basically what is required in a power system. We've got to be able to monitor, to actually be quite sure that this circuit breaker or this transformer is behaving like this, because it's only a few minutes, it's actually, because this is what is happening. You get to hear things, and then that tells you that this transformer is a few minutes from failure, and there isn't much you could do. But if we could actually use this technology to be able to predict, to be able to actually make sure that this transformer could actually remain in service the longest possible, and that will actually save utility a lot of money, in terms of asset condition management. Now, the beauty about the Internet of Things is that you do not need to have your data center nearby equipment, machines, or a system that you're actually trying to control or to monitor. And this actually could be done. You could actually have you can actually use cloud to store your data that is actually being gathered. And that enables us, or brings about, a new concept where you can actually own an entire power system, but being virtual. Meaning that if you look at what we have here, so looking at from generation right down to distribution, we can actually IoT the entire thing. We can actually implement the Internet of Things, gathering intelligence in generation, in transmission, in distribution, and being able actually to make decisions. Should we see something? Should the data actually tell us something? Because remember, data do not lie. People do lie, but data do not lie. Because we get data, we analyze this data, and we are actually able to actually tell. And by having that capability, we can actually own, and this is the concept that we're actually trying to bring about here, what is known now as virtual power plant, whereby we do not actually need to be wherever that generation station is. We do not need to actually be where transmission lines are. But because of the power that the IoT technology can actually bring, we can actually get this data into cloud using cloud computing, and then get them to a data center. So what we're trying to say here, the data center doesn't have to be in the same location whereby data is actually being guarded. And we can actually do remote condition monitoring in that particular manner. Now, we spoke about cognitive distribution automation, and really for the sake of time, I would like actually to move quite faster in terms of perhaps what is it that we actually proposing in terms of cognitive distribution automation. Now, what is being proposed? We can actually suggest that this basically these are the key steps. These are the fundamental steps that can drive this particular system. I mean, the cognitive distribution automation. So we have remote monitoring, remote monitoring is important. A smart energy metering comes as the second stage in this, and you could actually see that these arrows actually, this sequencing is actually being followed. And then we have fault management, you know, the detection of breakage in power lines, transformer issues, and these other devices. And then that gets us to predictive maintenance, which we spoke about. And then we do predictive maintenance so that we can actually get to know, you know, to know as early as possible on the condition of equipment and be able to make decisions. So should we do that, we can actually escalate that, you know, by bringing notifications that to people in charge to actually make corrective actions. And then we can actually create some form of mobile app in terms of, you know, being able, you know, facilitating operators to be able to execute certain actions should they be informed of something worrisome happening in an equipment or whatever may be the case. And then periodic reporting should be able to actually, you know, report on conditions, on whatever data could actually bring forth, and integration capability. So integration capabilities actually speaks to future energy systems, because that is the capability of integrating, you know, renewable data coming, you know, sustainability and all these kind of things. And then of course, geolocation, which is the ability to actually pinpoint, you know, pinpoint equipment, you know, from their particular locations, and to be able just to focus on that. So this is basically what cognitive distribution automation suggests. And now that brings us now now that is actually brings us to, you know, if you see condition monitoring, this is just to give you an idea that's what's the amount of benefit that IoT is actually bringing in terms of money in condition monitoring. Now, if you look at these figures, thanks to industry experts, this tells us that in 2019, and this is to say actually how South Africa, we're already late, because in 2019, this industry amounted for $2.6 billion. This you know, this industry, IoT in condition monitoring, and it is expected in year 2025 to actually reach $3.9 billion. And you could see now, this is basically around the world. This is around the world. It's not just in America or in North America, but you have all these regions of the world combined: North America, Europe, Africa, you know, Africa, and you have the Pacific Islands and the Caribbean, and of course the rest of the world. Now, to conclude this talk, Internet of Things actually brings quite a number of things, and part of that is actually what you call efficient condition monitoring of power system asset. And this is just one focus, condition monitoring. This is not to say IoT can only be used for condition monitoring. It can certainly be used for some other applications, but here we're actually focusing on condition monitoring. So it can actually, cognitive distribution automation can actually bring efficiency in what is being done currently. It can certainly improve energy security. It can actually create investment opportunity. Think of what we call the virtual power plant. You could actually own such a thing, employ people, but not really physically owning any power station, but you're just controlling the data. You have the data that come out from all the sections of a power system, and being able to actually do predictive, you know, do the analytics to be able to actually tell on the condition of every single equipment. Then it supports, certainly, when the IoT is actually being used, it supports the key attribute of future energy systems. And of course, we need not to make mistakes that this technology requires skilled labor or personnel to actually be involved. Now, talking about skilled labor or personnel, it actually brings me to, one of the powerful men of this continent when he says that, education is actually the most powerful weapon which one can use to actually change the world. And that brings us to, that actually puts some challenges ahead of us, to actually catch up in terms of, the demand of the fourth industrial revolution. Now, it's now time for me to actually thank you, all of you that's participate. And if you have any questions, I think I've actually indicated all my email address, or you can actually send your questions. I will gladly respond to them. Thank you very much.
Thank you very much, Prof. Bokoro, for a well-delivered presentation. Without waste of time, I'll dive in straight to the questions. For noting, if it happens that we don't get to your question, please note that we will still note your questions and email them to the presenter, and the answers to those questions will be posted on the SAIE website. Going straight now to the first question from Tadala Malua. Tadala wants to know, in your opinion, what would you say is one of the most practical approach in dealing with the supply depletion currently being experienced?
Well, a number of ways. Now, if you see, there can be many answers to that question, and depending on the key focus, because like I said, we're looking at three major issues there. We have issues of sustainability, which is quite important. You see, in certain regions of the world, this is, sustainability is such an issue. Now, but in some other parts of the world, people are still battling to actually, manage to have electricity for 24 hours. So it depends now what is the priority. But where we are, in South Africa, I think being a developing country, the energy security is such an issue, because being a developing country, we really want to make sure that the economy is actually booming to create jobs and all these things. Not actually to say sustainability is not an important issue, but I think supply reliability is such an issue, which actually requires investment, so that, because without that, it will be very difficult to attract investment and, develop this economy. So I think for me, and that is what the focus basically for this talk was on energy security.
Thank you, Prof, for that. The next question is from Mboyo. Mboyo is saying the electricity demand is actual fact, while the demand is increasing. Are the resources truly decreasing, or are we not intelligently researching the means to produce electricity? The next question from the same person is saying, the question is on the estimated demand of Africa, since the population will seriously grow, thus more demand. Are we not underestimating the potential demand for Africa based on the slide shown here? I think based on your figures that you indicated.
Yes, I would like to respond from the second question. It's not a question of really not underestimating the demand, because yes, it's true that in Africa we actually witness that the population is actually increasing, but population increasing, that one aspect, but in terms of population activity, that is a different fact, because you can actually get people increasing in numbers, but not being able to translate that increase in numbers in terms of real economic activity that will require, or that will actually, translate into electricity demand. And that is actually a fact, because if you see the current trends, yes, we're talking about China. China has more people than the rest of the world. But if you see, you cannot directly really link the fact that there is more people in China, that's why the demand is high. The demand is simply high. That translates in terms of people's activity, people's participation in economy. And that's basically what requires the need for energy. But in the African continent, that really doesn't seem to be the case. And in terms of the resources are seriously depleting, because we're talking about here the traditional resources that have been used for ever since, I think, about now 2 centuries since we are now dealing with electricity. Now, these traditional resources are actually depleting. Yes, there may be pockets, in the world, places in the world whereby these resources are still, but if you're looking at such places, for instance, let's speak about South Africa. In South Africa, we still have massive reserves of coal, but can the quantity of coal that South Africa has, can it actually service the rest of the world to meet the demand? I don't think so. So it is actually a fact that the traditional resources are depleting, and that is what justifies all this, all this talk about green energy, trying to rely on solar, on wind, and yeah, that is basically what justifies this.
Thank you, Prof. In the interest of time, I will take one more question and then we wrap up. The other questions, we'll post them on the SAIE website. So I'll take a question from H. Williams. The question is, are power lines multi-drop networks in operation yet to support the IoT devices, which will eliminate IoT cabling and wireless complications?
Well, I don't think, if they are currently, information in my possession actually indicates that it's actually quite, this industry is not really quite there. There is IoT being implemented in South Africa, perhaps in some other aspects, but not really in terms of remote condition monitoring of power system equipment. So that's what I say now. We need massive investment in terms of in that particular space, if we actually hope to curb all these issues that we're having here and there.
Thank you, Prof. I'd like to take this opportunity to thank you, Prof. Bokoro, for sharing your knowledge, wisdom, and experience with us this evening. I would also like to thank all attendees for attending this SAIE webinar today. Please remember to visit the SAIE website on www.saie.org.za for upcoming webinars and also for the answers to the questions that we did not get to. Thank you and goodbye.
Thank you, bye.